Hello, and welcome back to KSP Real Solar System campaign. With a successful Jupiter mission behind us, it is time we headed back to another planet that we really ought to have explored earlier. That is, of course, going to be Mars. With the science points that I gathered from our Jupiter exploration mission, I have unlocked several new modules. The most important of those new modules are going to be the new rover parts. We haven't had any rover parts yet, so we are definitely going to build a rover to explore Mars. And then we also have some extra large solar panels and various modules that are not really going to be that important on this mission. Now, we need to design a spacecraft that will complete our Mars mission. And we first of all need to establish the objectives that we're actually going to accomplish on Mars and basically what we want to do there. Due to the complexity of this spacecraft, we'll have to assemble the whole thing in different separate parts with a command and service module, a landing module, and a rover. And then finally we'll put everything together into one big final spacecraft. First of all, we need an orbiter, and the orbiter is going to have a command module, which I'm currently putting together on screen right now, and it needs to have all sorts of modules to support it: RTGs, a powerful antenna, service base, RCS, solar panels, scientific instruments, etc. The spacecraft itself will be called the Endeavour 2, and this is the command module. At the end of the command module we are also going to put a docking port. I was a bit unsure whether I should have this be a multiple launch spacecraft that would be assembled in space, but we'll get to that in a minute. Now we need to have a landing craft that's going to carry a rover within it, and we need to have a basic autonomous probe and a service bay on the bottom to store the rover. Now the engine design on this was going to be the most complicated part, and it is somewhat difficult to find a suitable engine for this type of mission. I tried different configurations. I tried the Asterisk engine, then a solid rocket booster, but none of those really fit the specifications that I wanted. I want some tiny engines that doesn't provide that much thrust. In the end though, I decided to use 6 of these tiny thrusters and a tiny fuel tank at the bottom, and then the benefit of this design is that those engines, they can be turned on and off as I want to. It has unlimited amounts of ignition, and they are so small that it is fairly easy to just put a heat shield underneath them. Now the next thing I need to do is design the rover itself, and I'm going to use a small Ranger core block, I think that is. Attach a few struts on the ends there, just to have a place where I can attach the wheels. It's going to be a fairly simple design, just a core, struts, and wheels. And the first wheels there were a bit large. I luckily had those smaller wheels as well. And after a little bit of tinkering and further design changes, I ended up with a fairly simple rover. The only thing I added here is an RTG as a power source, a battery, and an antenna, as well as the basic scientific instruments that we need. And you can see we're driving the rover around on around the space center here fairly well. Now back at the vehicle assembly building, we have to assemble the landing spacecraft and put the rover inside it. Unfortunately, the rover is too big for the service bay on this particular landing craft. So what I decided to do is see if I could fit the rover inside the service bay of the command module, and sure enough, there is enough space there. So I decided that I had to use the 4-meter service bay on the landing module itself, as you can see here, and that will be big enough for the rover to fit inside it. Of course, that means we do have to make some certain design changes as well. So now we just need to put the entire thing together and put the new service bay or the landing module at the bottom of the command module instead of the previous service bay. I was planning to use that for something else, but I don't think that's really going to be an option. So we attach the landing module to a docking port at the bottom of the command module and attach some struts for structural integrity. Now the final thing we have to do is design a service module for this entire thing, and it is going to carry the main engine of the spacecraft, and it is going to perform the various maneuvers we have to do in interplanetary space as well as in space around Mars. So it needs a fairly big engine, and we're using the same engine that was used on the Apollo service module. Then we also need some RCS for this, of course. And the last step is to put the service module at the end or the head of the command module. And the command module is going to be turned upside down because of this, but that is not really a problem. And originally I had intended to have the service module be launched separately from the command module, and then I could have docked the two in space around Earth, but I decided that it wasn't too impractical to have the entire spacecraft on the same launch, and it is certainly a benefit to avoid having some rendezvous and docking maneuvers in space around Earth. It makes things a bit easier for me, really. And now that the entire spacecraft has been assembled, it is time to design a booster for this thing, and we are going to reuse a familiar design from the same type of booster, kind of booster that was used on our previous moon missions, because this thing is pretty heavy, so we need a pretty big and powerful booster with 3 stages to launch this spacecraft into orbits and on a course towards Mars. And in the first stage, I'm again going to utilize 5 F1 engines, which is necessary to provide enough thrusts at the launch pad for this rocket. Now I'm also going to use asparagus staging on this first stage because we have unlocked fuel lines now. So until now we haven't been able to utilize asparagus staging, but it's going to add a little bit of delta V to this mission, which is certainly nice. Now, before we actually launch to Mars, because we're not in the launch window yet, and if I bring up the orbit info, you can see that Mars has a phase angle of 263 degrees. It needs to be about 45. So we're pretty far away from the actual launch window, but I want to do a test run of this rocket you can see here, which is the full spacecraft that I do intend to send to Mars, but we are going to do a test run to see if all the systems works and if you have to do some kind of modifications before we actually go for our mission. The Mars rocket has now finished construction, except we are not going to take this to Mars just yet. You can see at the planet phase angle here that Mars is at 263 degrees. and launch window is around 45 degrees, so we are far off from a Mars launch window. The thing I want to do though is do a test run of this rocket and see if all the system works and if all the bits and bobs in the rocket and the final spacecraft are working as intended. So we are just going to take this into low Earth orbit, and well, I guess we could take it to the moon as well. It certainly has the power to do so. But we'll see about that. Now, one of the things I'm going to have to get used to here is the low thrust-to-weight ratio on the first stage, and we are using asparagus staging here, so the thrust-to-weight ratio is going to get progressively worse as we burn through the strap-on boosters. And on the final core booster here, this one, the thrust is going to be pretty low, so we'll have to compensate for that and make sure we don't fall back to Earth. But again, this is just a testing run, and I can get used to the launch profile of this particular rocket on this flight. I'm going to separate the two first strap-on boosters any second now. Let's see. Yep, we have a successful separation of the two first strap-on boosters. So now we only have 3 F1 engines pushing this into space, and then eventually we are only going to have 1. And we are going for separation of the 3rd and 4th booster here, and now we only have this central core engine pushing the rocket into space. I'm gonna have to decouple and launch the 2nd stage immediately. There we go. This is of course using liquid hydrogen, liquid oxygen in a 4J2 engine configuration, and this will take us into orbit just fine. Right, so we do have a decent enough orbit right now, and we are going to do some tests here. There is something I forgot on this lander module, which is what I want to test most of all. The problem here is that the lander module by itself is too heavy for its own avionics. So if we decouple this, it's not going to have any control. But what we can do is decouple the whole thing, like this. Let's just try to pull away here from the main spacecraft. I'm going to bring this whole thing back into the atmosphere and see how it balances out. So I'm going to go for re-entry right here. I just need to get this pointed in the right way. I can use the main engine here. So we are going to deorbit this, see how it performs aerodynamically. Or I guess once you get into the atmosphere you can just decouple and let this other stage burn up, which is a shame because it's a pretty advanced spacecraft, and it's, yeah, I wouldn't like to launch this to the moon because it would have been a perfect moon exploration vehicle. But I guess the moon missions, moon rovers and so on will have to come at a later stage. So we're going to bring the periaps down to, I guess, 65 kilometers. Should be nice. And soon we are going to get, well, somewhat an answer to the question of how well this will actually perform in the atmosphere. Since this landing module over here is too heavy, We can't actually turn on the landing engines here, but they does have parachutes, which I believe we can turn on. And the engines are only really necessary for a Mars landing where the atmosphere is so thin. So then see if I can... There we go. Now, let's decouple. Oh, and it sort of bounced off. Which... but if this is shaped in the correct aerodynamical way, it should be able to balance itself back again, and it does look like it will do that, because it is starting to veer back ever so slightly towards the marker over here. So we are getting some heat right now, and it has kind of balanced the correct way, but not completely. And there we go, it explodes. Well, that was that. But again, this was a test, and we have successfully tested whether this worked, and it's almost worked as intended, but we are going to have to do some design changes here, certainly. But that will be it for this episode of KSP Real Solar System Campaign and OR Pro. Oh, there it goes. Is there anything left here? Anyway, this is it for this episode of KSP Real Solar System Campaign. I hope you enjoyed this video, and I hope to see you in the next video, where we will hopefully launch our mission to Mars. So take care and bye.